graphing calculator with you and you want to follow along, I invite you to take that out and follow along. If you want to just sit and watch, that's fine too, but like keep in mind that this video has the instructions on like how walking through using the calculator to do some stuff. You too. Good luck tonight.
Right.
Yep. So the equation for this problem was that guy. So I'm going to just start by typing that in. So x cubed minus 6x squared plus 9x. Oops. X. Everybody, so far so good? Okay. Now, to find part A, to find the velocity, what we had to do was take the derivative, right? Now, your calculator can't give you the symbolic answer for the derivative, but it can give you the graph of the derivative. Let me show you how to do that. So I'm going to go to y2. And in y2, I'm going to graph the derivative. So to do that, I'm going to press the math button. And I'm going to scroll down to command number 8 that says n derive. You should look, this notation now should look kind of familiar. What variable should be going here at the bottom of my D? Yes, good. And what should be on the inside? Where are we taking the derivative of? Right, or I could just use y1. That's what I'm going to type so I don't accidentally make a typo. So to find the y1, I press vars. I go over to yvars. Vars is short for variables. In this class, we'll only be working in function mode. And here are my y functions, so I'll do y1. And now your calculator can only do like a definite derivative, like the derivative of whatever at x equals a specific value. And we don't want a specific value of x, we want all values of x. And since we're graphing it, the calculator can do that if we just type x there. So I'll just zoom standard, get like a normal window. There's the original function, there's the derivative. And so when we did this by hand, we said that our answer should have been 3x squared minus 12x plus 9. So if I graph this, what should I notice with y2 and y3? They should be the exact same graph, right? What have I just shown you?
Check.
Yeah, you can now check. Like any derivative you take, right? You can check. You type the original into the calculator, you have the calculator graph the derivative, you type your answer to the derivative and make sure they match.
How did you get the derivative button again?
So I did math, and then I looked for the n derive command. I get to 8 on my calculator. Now, fair word of warning. If you go back and we look at like, oops, not this one. Where did you go? Did I not put them in here? Oh, there they are. If you go and you look at these terrible ones, like you may have, there's going to be some domain weirdness going on. May not match exactly. So like if it's crazy complicated, the check is not the end all be all of checks, but you know, it's better than nothing. It's something, right? It's like that seems pretty helpful, Mr. Gulick. Oops. That is where we're at. Okay. All right. What is the velocity at 2 or 4? So again, what I can do there is I can go to the main screen. I can do math and derive of y1 at x equals 2. Number spits out. I can just update that. Y4 number spits out. On a test, particularly an AP exam, if you have the access to the calculator and you're asked to find a derivative at a specific value, do not do this by hand. Use the calculator to do it, right? Like, part of what they're going to do on the AP exam is they're going to give you problems that are 30-second problems on a calculator and are 3-4 minutes without it. The only way to finish and have time to really think about all your questions is to recognize the ones that should take 30 seconds and choose the appropriate tool. So the ones that are like, that's a 5-minute problem no matter what, you have time to take 5 minutes to do it. Because that's the way the multiple choice is going to work. There's going to be problems that are like, that's a 5-minute problem regardless, or maybe even a 7-minute problem regardless. And the only way to have time to do those problems is by finding all the 30-second problems and having those be 30-second problems and banking those minutes. Okay? That's what separates 4s and 5s from like 2s and 3s. It's not because you know more, it's because you're faster and you recognize the easy way to do things and you do the easy way to do it. So you can make a 30-second problem instead of having a 2-minute problem or a 5-minute problem. Okay? When is the particle at rest? What are we trying to do there? Well, we're just solving where the derivative is 0, right? Am I going to do that by hand? No, I'm going to use my calculator, right? What do I do to find where the derivative is 0?
Just change the domain.
Second, trace, 0 command, right? So I change to my derivative function, left bound, right bound, guess. There's one solution. Repeat. Is everybody okay with that? You remember finding zeros with your calculator in Algebra 2 and pre-calculus? Yes? Okay. Again, if you have a test and it's a calculator open test, I'm not solving at least that's my first pass, is I'm not solving. Now, if all the answers in multiple choice are like exact answers, I'm still not solving by hand. I'm still going to use the calculator, get the decimal, type in the 4 exact answers and see which one matches my decimal, right? Like, I'm not doing it by hand. I'm going to save all the time I can and avoid having to like grind through a bunch of algebra and look for a mistake when I like dropped a negative sign or like it's copied something down wrong or whatever. Like, I'm going to try to be as efficient and careful as possible, and using the calculator well is part of that. Does that make sense, guys? So when is the particle moving forward? We said that was when the derivative is greater than 0. I can look at the graph and tell. I don't need to draw a sign diagram, right? It's that part and that part, just where it's above the x-axis. So I have the answers for the zeros from the previous one. So I know it's 0 to 1, and then 3 to positive infinity. No big deal. If I want to find the acceleration, again, I can't do that manually, but I can do that, find the graph of it with the calculator. How am I going to find the second derivative? I'm just going to do the derivative of y2. Yeah, I'm just going to nest the derivative operations here. Oops, that's not what I wanted to do. X. Bars, y bars, function y2 is x. So there's my second derivative. That's my graph for acceleration. Again, super easy to see where the acceleration is 0 or positive or negative just by looking at the picture. If I wasn't sure where it crossed, I can always just use the 0 command to find it. Yeah, everybody feel good about the calculator piece? It's a good tool, right? I took my time to show you what it can do intentionally because I want just to have the algebraic methods, because half of your exam is no calculator. You gotta be able to do it without it. But like, when the calculator becomes open, it's nice to have, this is the easy way to do this, the fast way to do this. 310 is about a process called linear approximation. You know what? We already know how to do this. All a linear approximation means is you're going to create the equation for the tangent line, and then you're going to use the tangent line to approximate values for y out of it. So you just plug a new x into your equation, your line, equation for a line, and you get a new y value, and that's your approximation. That's so beautifully simple, right? So they do all of this mumbo jumbo in the book. It's senseless. I don't care, don't care, don't care, don't care. So let's do this. Okay, so we have this curve. And we want to look at the difference in the curve and its approximation at some specific values. Actually, I don't want to do any of this. This is dumb. I don't like the way the book does this at all, to be honest with you. I don't know why I've even bothered to keep this. Let's do this. No, it's not this one. This one.
No.
Oh, that is so good. He fits it too.
I want. There we go. This is what I want. So this is how this would be presented to you on the AP exam. A differentiable function f has the property that f of 5 is equal to 3, f prime of 5 is 4. What is the estimate of 4.8, f of 4.8 using the linear approximation at 5? That's a point. That's a slope. That's my linear approximation. I'm just plugging 4.8 in. That's all we're talking about when we talk about linear approximation. That's as much as you need to do. Don't worry about any of the differential nonsense or like estimating errors or whatever. Because that's the way they'll present it to you. They'll just give you points, they'll value the derivative at a specific place, and ask you to make an approximation. Whenever you hear linear approximation, think tangent line, and you're just using that to make an approximation, to make an estimate. Like you did when you wrote a regression equation in algebra 2 or calculus, right? You write a y equals mx plus b to approximate data in a data set. Same idea, we're just making a y equals mx plus b to approximate values in the function. Now, what should happen in terms of the accuracy of our approximation? The closer the x is to 5, the better my approximation should be. The further away I get from that, the less reliable that approximation should be. So this is really like a close proximity matters here, but that's the idea. That's the only idea for 310 we need to work about. Is can you write an equation for a tangent line and use it to make an approximation? I think we've been writing equations for tangent lines for a minute, shouldn't be too bad. Still okay? Yeah, so that's kind of the gist of it. That's chapter 3. We'll do some review next week. I think the earliest possible test date we look at is Thursday, but we'll see how the week goes. Okay, see how Tuesday goes, and we'll make a decision about test date then. Sound okay? Again, if your schedule for next week looks terrible, let me know. Okay? But I would start looking at the MCQs and FRQs here. Obviously not tonight, it's Halloween, it's a football game, like I'm doing today. But like, start kind of thinking about finding some minutes here and there to pick away at some of those and get a feel for how you feel about what we've been doing. Like your biggest skills are like, you just take a derivative and find that symbolic answer, like we did in 3.4. And you have all these rules now, right? That you have to have memorized. And then the implicit differentiation piece, you got to make sure that we're good on there. We recognize when there's a product or quotient interchangeable going on, and we get the dy dx's in there. That becomes really important when we circle back to 3.9, which we'll do in the next test. But the implicit differentiation thing is not going to go away. That circles back on us. And I can't remember if I mentioned it or not. But I know on My Notre Dame I put in the links section, I made a Quizlet for the derivative shortcuts. So that's there. Now, I apologize for the formatting. Because they I had to write it with the keyboard because it doesn't let me do the math type in there, and I didn't want to spend this is the one and only Quizlet I ever written, so I wasn't invested enough to want to figure out how to put a picture in instead and handwrite stuff, so I just typed it in as best I could. But it's there for you guys to look at. So that's there. Yes, please.
So with 3.7 homework and 3.10 homework, we do this Sunday as well?
I don't think it needs to be. Does it make your life easier if it's not?
I mean, either way.
Yeah. Again, you're gonna do it at some point, right? Whether to do this weekend or next weekend, if it's easier on you, do it next weekend. That's fine.
Yeah.
So we're through 3-6 for Sunday. Everything after 3-6 next week. Sound good?
So we're not gonna have a homework.
This was the last homework quiz before testing, before testing. We're done with those. Well, no, we have homework quizzes still coming. Because I think some of the hardest thing to do in the first semester is still yet to come.
We close the ways back. Done the hardest thing?
I don't think so. It's related rates and optimization. It's the next stuff.
God bless.
But it's one of those things it's hard not because it's calculus is hard. It's hard because you have to read a story problem.
It was
And everybody's like, oh, I hate that. Sorry, it's not all symbol pushing all the time. The hard symbol pushing can't do it. It's oh, I have to really understand what's going on here. Oh, no. Or I have to use my imagination to picture the situation. Do you want to picture? Most of the related rate situations are geometric. Which, like, is nice because you have like a physical thing to picture, but your imagination isn't very good. That can be hard. Of course. So anyway, that's what's coming up.
Can you perchance do that there earlier? I wanted to say,
This one?
number 2.
Number 2?
Yeah.
On the calculator, man. If I have access to the calculator, that's what I'm using, right? If I don't, that's a different story, but now if I'm doing it by hand, so it's a chain rule. So the derivative of the outside is 4x to the third times the derivative of the inside. So I'm just plugging in 1. So it's going to be -8 times 8.
And then we got the y, right? So
Chain rule, right?
Yes. Yes. 100%. As you're looking through these, periodically you'll see this symbol. That means that this is a question that would have come from my calculator active portion. So like when you see those problems, you should think, how should I do this with my calculator to make it easier? Sometimes there's not an answer, sometimes there's not a way to make it easier with the calculator. But that's what that symbol means on these multiple choice questions or the 3 responses, is this would come from a calculator active portion of an AP exam. So keep that in mind as you're doing that. Now this one doesn't really help you do the problem other than you can use the calculator as a checker, right? Once you've done your derivative. But, yes.
yeah.
No, it's a double chain. It's a double chain.
Okay.
Please walk up.